Okay. All right, so now let's do problem number 4, which is y equals x squared e to the negative 1 over x. 4? Okay. So we want to find, our goal is to find, sorry about that. Our goal is to find y prime. Okay, so we are going to need to use the product rule because we've got x squared times e to the negative x. Okay, so we're going to need to do the product rule. So we can, in fact, just label this as f of x. So this is our f of x. And we're going to label this as our g of x. So using the product rule, y prime is going to equal x squared prime times e to the negative 1 over x plus x squared times e to the negative 1 over x quantity prime. Okay? I'm trying to do a prime sign here. Okay. So I need the derivative of x squared and the derivative of e to the negative 1 over x. Okay, this first one is going to be easy because the derivative of x squared is just 2x. However, the second one, this is going to need us to use the chain rule. So our outer function is going to be e to the x, and the inner function is going to be negative 1 over x. So if we, now let me in fact go back up here and we're going to erase that because I want to use f and g for these outer and inner functions. So our outer function, little f of x, is e to the x, and the inner function, little g of x, is negative 1 over x. So I need f prime of x. It's going to be e to the x because f of x is e to the x. And g prime of x, well, now how do I figure out g prime of x? Well, let's rewrite g of x. So if g of x is equal to negative 1 over x, that's the same thing as negative x to the negative 1. And now we can use the power rule to say we're going to have negative 1, bring it down, and then, right, so we'll have, so the negative stays the same. Now we've got negative 1, we brought down, and then x to the negative 1 minus 1, so we'll have x to the negative 2. And we'll have two negatives canceling out, so it'll be positive x to the negative 2. So this is our derivative here, x to the negative 2, which is the same thing as 1 over x squared. Okay. So what is the derivative? So let's see here. So e to the negative 1 over x prime is going to be equal to f prime of g of x times g prime of x. F prime is e to the x, right? So we'll have e to the g of x times g prime of x. What is g of x? G of x is negative 1 over x. So we'll have e to the negative 1 over x times, and what is g prime? G prime is 1 over x squared, 1 over x squared. So we'll have e to the negative 1 over x squared, and we could even write that as 1 over x squared e to the 1 over x. Okay, so let's try to put this all together here. So here's what we have. So to recap, this is equal to, this derivative is equal to 1 over x squared e to the 1 over x. Okay. Or we can write it as x to the negative 2, e to the negative 1 over x. Okay, so now I'm going to erase so I can have space. So let's see here. So let me copy this, paste. All right, so here we go. At this point, we're essentially just dropping things in. So we said that that the derivative of x squared is equal to 2x. So let's write this as 2x times e to the negative 1 over x plus, and then the x squared stays the same, but the derivative of e to the negative 1 over x is, let's see here, x squared, or x to the negative 2, to the negative 2, e to the negative 1 over x. Okay, and now when we simplify, we'll have 2x e to the negative 1 over x plus x squared, x to the negative 2, e to the negative 1 over x. Now the x squared and the e to the negative x are going to cancel each other out. So we'll just have 2x e to the negative 1 over x plus e to the negative 1 over x. And we can factor out e to the negative 1 over x. And what's left will be 2x plus 1. So that is our answer. Let's just use our red. Okay. Let's go to the next one. Now, the key for this one here is to rewrite your function. So the first thing we're going to do is rewrite the function. So we can rewrite this as something to the 1/2, right? So look in here, and it's all of this to the 1/2. So let's just put that in here. So x plus the square root of x plus the square root of x. So it's all of that to the 1/2. And now we can redo this. So this, so let's use different colors now. So this we're going to rewrite. So square root of x, we're going to write that as x to the 1/2. Okay. To it, we are adding x. All of this, we're taking the square root of. And then we're adding x. And then taking the square root of all of this. So this is how we rewrite it. And this will make it easier for us to essentially do the chain rule many times. Okay. So now our outer function is just x to the 1/2. And our inner function is x plus quantity to the 1/2, x plus x to the 1/2. Okay. So if this is our f of x and this is our g of x, y prime, so let's just kind of keep track of everything over here. Y prime is going to be equal to, in fact, let me just make a thick barrier here. Okay. So y prime is going to equal f prime of g of x times g prime of x, right? Okay. Now over here, our f of x is x to the 1/2. So f of x, f prime of x, is going to be equal to 1/2 x to the minus 1/2. And that means that f prime of g of x is going to be 1/2 g of x to the minus 1/2. So let's put that in here. So we'll have 1/2 g of x to the minus 1/2. All of that times g prime of x. Now our g of x is equal to x plus the square root of this stuff. So in order to figure out the derivative of g of x, x plus, and all this to the 1/2, we need the derivative of all of this, right? So x plus x to the 1/2. Now, this is going to be the same thing as taking the derivative of x and the derivative of x plus x to the 1/2 to the 1/2 power. Another way to write this is, so another way to write this expression is you could also write it as the derivative with respect to x. Remember, this is using our Leibniz notation. X plus x to the 1/2 to the 1/2. Okay? And then you're saying this is equal to the derivative with respect to x of x plus the derivative with respect to x of x plus x to the 1/2 to the 1/2. Okay, so either way is fine. So let's see here. So g prime of x is going to be d dx of x plus the derivative with respect to x of x plus x to the 1/2. All of that to the 1/2 power. Okay. Now, we know the derivative with respect to x of x, that's just equal to 1. But in order to find this derivative, we need to use the chain rule. Okay, so now how do we find the derivative? So now we're going to focus on, so I'm actually going to add a page after, add a page below. Okay. And here I'm going to find the derivative of x plus x to the 1/2, all of that to the 1/2. Okay. Because then I'll be able to put it back into here and we'll have our g prime, which we can then put up here. Okay. So now how do I find this derivative? Okay. So my outer function is x to the 1/2 and my inner function is x plus x to the 1/2. Okay. So now let's call this my f of x. Notice this is not the same f of x and g of x as before, but this is the f and the g that we need in order to use the chain rule for this current problem. So you've essentially got a problem within a problem. Okay, so now f prime of x is going to equal 1/2 x to the minus 1/2. I'm just using the power rule. And g prime of x is going to equal 1 plus 1/2 x to the minus 1/2. Okay? So I just took the derivative of x, that gives me 1, and then I took the derivative of x to the 1/2, that gave me 1/2 x to the minus 1/2. Okay, so so the derivative, this derivative that I want of this with the 1/2 x plus x to the 1/2 is going to be f prime of g of x times g prime of x. Okay, so I've got my f prime of x, this is the formula. So f prime of g of x is going to be 1/2 g of x to the minus 1/2. And then I've got my formula for g prime of x, which is just 1 plus 1/2 x to the minus 1/2. And I put parentheses around that so that I can have the correct order of operations. So I can rewrite this as 1/2 1 over square root of g of x times the quantity 1 plus 1 over 2 square root of x. Okay, so I get 1 plus 1 over 2 square root of x all over 2 square root of g of x. But remember, what was g of x? G of x was up here. G of x was x plus the square root of x. So I have 1 plus 1 over 2 square root of x over 2 times the square root of x plus x to the 1/2. So this is going to be equal to, now to simplify, I'm going to multiply the top and the bottom by 2 root x. So now this times this is going to give me 2 root x. This times this is going to give me plus 1. And then the denominator, I'll just have, so this 2 and this 2 I can put as 4. Then I have a square root of x. Then I have a square root of x plus square root of x. Okay? So now, let's copy. I'm trying to copy. And I will now paste. Okay, let me erase. And I can now put in this derivative. What is this derivative? This derivative is, so I've got 1 plus 2 root x over 4 root x times root x plus root x. All right, and now this is my derivative for g prime. And so I can put it in this equation over here. So my y prime is equal to 1/2 1 over, what is this? The square root of g of x. Now over here, what is this? I've got x. So see, I've got to use, what do I have to use? I need to use this formula right here for this g, right? So I'm going to have square root of x plus square root of x square root of all of that. Okay, that's g. Wait a minute. I think I need to be more careful. So I'm going to erase that for now. And I'm just going to say y prime is equal to 1 over 2 times 1 over the square root of g of x times g prime of x. But my g prime of x is going to be one plus 2 root x over 4 root x squared plus x root x. Okay. Okay. So now I think I'm actually going to need more space. So this is going to be y prime equals 1 over 2 times 1 over the square root of g of x. What is g of x? G of x is x plus x to the 1/2, all of that to the 1/2. So I've got that. And then times 1 plus 2 root x over 4 root x squared plus x root x. Okay, so if we were to write this, we would have 1 over 2 times, in the denominator, we'll have x plus the square root of x plus the square root of x. And then I need the square root of all of that. Okay, times 1 times, now I can find a common denominator, 4 times the square root of x squared plus x root x plus 1 plus 2 root x, all divided by 4 times the square root of x plus x squared plus x root x. And I'm sure this can be simplified, but I'm not going to. So I'll just put it as a, let's see, we'll put a little red box around it, and as my advisor at UC Berkeley would say, call it a victory. Declare victory, we're done. Okay. So this is our answer for this one. So that's a long one, and the reason why it's so long is because we need to do essentially 2 or 3 chain rules, right? So chain rule within chain rule to get our original derivative. Okay. So now we're on to the word problems. Find the x-coordinates of all points on which the curve y equals sine 2x minus 2 sine x, at which the tangent line is horizontal. So here's the key. The key to solving this is you've got to know. What do you got to know? Got to know. Tangent line is horizontal means derivative is equal to 0. So this is going to be our guiding principle, okay? So now we need to find the x-coordinates of all points on this curve here. Our curve is here, at which, and then instead of saying the tangent line is horizontal, at which, so instead of saying the tangent line is horizontal, we're going to say the derivative is 0. Y prime equals 0. So that's essentially what we're trying to find. So what this means is we need to find y prime. So we've got y equals sine of 2x minus 2 sine x. Y prime equals, so we need d dx of sine 2x minus d dx of 2 sine x. The derivative of 2 sine x is going to be minus 2 cosine x, and we need to figure out the derivative of sine 2x. Okay, so we're going to go over here, up here actually, and try to find the derivative of, let's put a little box here, of sine 2x. We're going to use the chain rule. What is our outer function? It's just going to be sine x, and our inner function is going to be 2x. So f of x is sine x, g of x is 2x. So f prime of x is cosine x, and g prime of x is 2. So f prime of g of x, g prime of x, is going to equal f prime of g of x, so we need cosine of g of x, times 2 Okay. And then what is cosine of g of x? Well, g of x is 2x, right? So we'll have cosine of 2x times 2. And the way to write this so it doesn't look like cosine of 4x is to put 2 cosine 2x. Okay. So down here we'll have 2 cosine 2x. So now, can we combine this? No, we cannot, because the argument of cosine is x over here and 2x here. So we can't simplify, and we just leave it as is. So we found, so y prime is equal to 2 cosine 2x minus 2 cosine x. So that, are we done? No, we are not. This is step 1. And then step 2 is going to be to solve for x. Two cosine 2x minus 2 cosine x equals 0. So this is step 2. Now, I'm actually going to add another page, add page below. What this is essentially a problem from trigonometry, math 50. And paste. Paste. Okay, so we got to solve for x. And how we're going to do it, in order to do this, we will need to, because of this 2x, we need to use our addition formula. So, recall, or look up, recall that cosine of 2x is equal to cosine of x squared minus sine of x squared. Okay, so this is a trig identity. So now, back here, we can rewrite this left-hand side as 2 times cosine x squared minus sine x squared minus 2 cosine x equals 0. And so we'll have 2 cosine x squared minus 2 sine x squared minus 2 cosine x equals 0. Divide everything by 2, divide both sides by 2. So we'll have cosine x squared minus sine x squared minus cosine x equals 0. And what do we do? Well, it's kind of hard to navigate the cosine squared and the sine squared. So what we'll do is, let's add sine squared to both sides. So we'll have cosine x squared minus cosine x equals sine x squared. Now here's another trig identity, which is that cosine squared x plus sine squared x equals 1, right? So isn't that essentially what we have here? We've got cosine squared x minus cosine x equals sine squared x. From this trig identity, sine squared x is equal to 1 minus cosine squared x, right? So let's just substitute for sine squared x, 1 minus cosine squared x equals cosine squared x minus cosine x. We're going to add cosine squared x to both sides, plus cosine squared x plus cosine squared x. And we now have 1 equals 2 cosine squared x minus cosine x. Okay. Now, 2 cosine squared x minus cosine x minus 1 equals 0. Here we are now going to do a U-substitution. So let U equal cosine x. Then this becomes u squared. This becomes u. So we have 2u squared minus u minus 1 equals 0, which means u squared equals, I'm going to use a quadratic formula, so negative b plus or minus square root b squared minus 4ac over 2a, okay, which is equal to 1 plus or minus the square root 1, was that minus negative 8, so that'll be plus 8 over 4. So we get 1 plus or minus 3 over 4. So 1 plus 3 will be 4 over 4, or 1 minus 3, negative 2 over 4. So we get 1 or negative 1/2. This should be u. So u equals 1 or u equals negative 1/2. What is u? U is cosine of x. So cosine of x equals 1 or cosine of x equals negative 1/2. And we look at our trig, our unit circle. And for our unit circle, when is cosine? Let's go to unit circle. So when is the cosine? Just click any image here. We need cosine of x equals 1. And when is cosine of x equal to 1? On when x is equal to 0. Cosine is the first coordinate. So cosine is equal to 1 when x is equal to 0. 2 pi. So x equals 0, 2 pi, 4 pi, negative 2 pi, negative 4 pi, etc. Another way to write that is x equals 2 pi k, right? For any integer. Okay. And now cosine x equals negative 1/2. When is cosine equal to negative 1/2? Cosine is equal to negative 1/2 at 2 pi over 3 or 4 pi over 3. So x equals 2 pi over 3 plus 2 pi k, or 4 pi over 3 plus 2 pi k. Okay, so the final answer is, for step 2, is when is this true? When x equals 2 pi k, 2 pi over 3 plus 2 pi k, or 4 pi over 3 plus 2 pi k. And this is true for any integer k. Okay, so this was a pretty long problem. I'm glad we did it because it kind of highlights really the application, right? The application of the chain rule. So we've got infinitely many answers. So infinitely many solutions. Okay? And we could probably graph y equals sine 2x minus 2 sine x, and we would see that you're attaining some max or min. So notice these are all critical points, infinitely many critical points as well. Okay, and last but not least, let's do this example here, where we want to find an equation of the tangent line to the curve y equals sine x at the point pi comma 0. Okay, so for this problem, we've essentially got, we've got to know just a few facts. So let's see here. So we need to know the equation of the tangent line. The formula for that is going to be y equals f of a plus f prime of a times x minus a. So we need to know this. We need to know what is a, what is f of a, and what is f prime of a. That's what we essentially need to know. Once we find a, f prime of a, and f of a, we'll plug them in here, and we'll have our solution. So in fact, let me just write our solution down here. Y equals f of a plus f prime of a times x minus a. And I'm even going to put it in a red box to signify that this literally is going to be the format of the solution. Okay, now, what is a? So let's do this one first. What is a? We get a from here. So this is going to be a, and f of a is going to be 0. So now if we were to graph y equals sine of sine x, let me try to graph it quickly on Desmos. It's y equals sine of sine x. And I'll just kind of show you a sketch. So sine of x is actually pretty. So when you graph it, it looks something like, so this is 1, this is -1, 2, 4, -2, -4, 3. So it's looking very similar to sine. It looks very similar to sine. So this is x, and this is y equals sine of sine of x. Okay? So at the point pi comma 0, this is the point here. So this point here, pi comma 0, is this point right here. So we want to know what is the equation of the tangent line to the curve at this point. Right? That's our goal. What's the equation of this line? And so the goal is equation of this line. And this line goes through the point pi comma 0. So a is equal to pi, and f of a is equal to 0. So we can go down here into our solution and subtract a, or erase a, and put in pi. And for f of a, just going to put in 0. The last thing we need to do is figure out f prime of a. So let's do that here. Okay. So our function, f of x, is equal to sine of x, and we need f prime of pi, right? Because that's going to be f prime of a. Since a is equal to pi, we need f prime of pi. So first let's find a formula for f prime of x. What is f prime of x? Okay, we'll have again our inner and our outer. Perfect time to use the chain rule. Outer function is going to be sine of x. Inner function is going to be sine of x. So this is our f of x, and this is our g of x. So let me go back here and change this to big F, and change this to big F prime. Okay, and we need big F prime of pi. All right, so what is our f prime of x? If f of x is sine x, f prime is cosine x. If g of x is sine x, g prime is cosine x. So now putting it all together, right, because our f prime of x is going to be little f prime of g of x times g prime of x, which is going to equal cosine of g of x times cosine of x. What is g of x? G of x is sine x, so we'll have cosine of sine x times cosine of x. All right. Now what we need is f prime of pi, so this is going to be cosine of sine of pi times cosine of pi. Now, what is sine of pi? 0. So cosine of 0 times cosine of pi. What is cosine of 0? 1. What is cosine of pi? -1. So our f prime of pi is going to be equal to -1. And we put that down here. -1. Okay, so we could write it a little neater here. So we could have minus, right, 0 minus quantity x minus pi, which is the same thing as pi minus x. We have 0 minus x minus pi, which is the same thing as just pi minus x. And that is it. Please practice. Thank you.